Bismillahirrahmanirrahim. Chapter number 6, Transition Elements, MCQs. The color of transition metal complexes is due to dd transition of electrons. F block elements are also called inner transition metals. Coordination number of platinum is 6. The non-typical transition element is zinc, and the following is which one of the following is a typical transition metal is cobalt. Which of the following has greatest number of unpaired electrons? It's manganese. The total number of transition elements is 58. Coordination number of platinum in this complex is 6. Group 6b of transition element contains chromium, molybdenum and tungsten. The strength of binding energy of transition elements depends upon number of unpaired electrons. Short question answers, textbook exercise. Question number 1, 6.2. Properties of transition elements. How does electronic configuration of valence shell affect binding energy of the transition elements? How does the electronic configuration of valence shell affect binding energy of the transition elements? Or why binding energy increases up to vanadium and then decreases up to zinc? When we move from left to right in 3D series of transition elements, the number of unpaired electrons increase up to groups 5b and 6b. After that, pairing takes place and number of unpaired electron goes on decreasing until it becomes 0 to group 2b at group B2b. Therefore, binding energy is maximum up to group 6b and weakens progressively up to group 2b. Manganese has somewhat low binding energy. In the third transition series, increases in binding energy ends at tungsten when all the 5d electrons contribute to binding. Binding energy ends at tungsten when all the 5d electrons contribute to binding. So, question number 2. How does the electronic configuration of valence shell affect paramagnetism of the transition elements? How does the electronic configuration of valence shell affect paramagnetism of the transition elements? Or why the maximum paramagnetic strength is associated with the middle atoms of d block series? Why the maximum paramagnetic strength is associated with the middle elements of d block series? The paramagnetic behavior is strongest for ferrous 3 positive ion and manganese 2 positive ion, and decreases on both sides of the first transition series. The reason is that both manganese and ferrous have 5 unpaired electrons each. The number of unpaired electrons decreases gradually to 0 on both sides of the series. Question number 3. How does the electronic configuration of valence shell affect melting points of the transition elements? Give reason that melting point and boiling point show maximum value in the middle of first ionization series. Transition metals have very high melting and boiling points due to strong binding forces present between their atoms. Melting points increase up to the middle of the series and then decrease up to a minimum level at the end of the series. Melting points and boiling points of elements is directly related with the strength of binding forces. Greater is the strength of bond, greater will be the melting and boiling points. Give a reason that melting point and boiling point shows maximum value in the middle of first ionization series. Show maximum value. Melting and boiling point show maximum value in the middle of first ionization series. Transition metals have very high melting and boiling points due to the strong binding forces present between their atoms. Melting points increase up to the middle of the series and then decrease to a minimum level at the end of the series. Melting points and boiling points of elements is directly related with the strength of binding forces. Greater is the strength of bond, greater will be the melting and boiling points. Why transition metal have variable oxidation state? Why transition elements usually show more than one oxidation states in their compounds? They show variable valencies because of the involvement of unpaired d electrons in addition to s electrons in bond formation. All the 3d elements, series elements, show an oxidation state of +2 in addition to higher oxidation state. Manganese has highest oxidation state +7 among the first transition series. After manganese, the number of oxidation states decrease as the d subshell fills up. A fewer unpaired electrons are available for bond formation. Damaged tin plate iron. Why does damaged tin plate iron get rusted quickly? If the protective coat of tin is damaged, then the iron comes in contact with moisture. A galvanic cell is established in which tin acts as a cathode in which tin acts as a cathode and iron acts as a node. Anode means positive and cathode is negative. The electrons move from iron to tin, where they discharge H positive ions. The electrons move from iron to tin, where they discharge H positive ions, leaving behind OH negative in the solution. These OH ions combines with iron and forms ferrous OH whole thrice, which dissolves rapidly in water. Ferrous 3 positive plus 3 OH negative gives us Fe OH whole thrice. So the damaged tin plated iron gets rusted more quickly due to the fact that water promotes the electrochemical oxidation of iron. Because water promotes the electrochemical oxidation of iron. Under what conditions does aluminum corrode? The main conditions for corrosion of aluminum are presence of moisture, presence of impurities which must be less reactive than aluminum. Example: zinc, chromium, ferrous and cadmium, etc. Presence of air or oxygen. When an active metal aluminum comes in contact with less active metals like zinc, copper, ferrous and antimony and strontium, that is having greater reduction potential than aluminum, a galvanic cell is established in the presence of moisture in the cell. Aluminum acts as anode, while metals like zinc, ferrous, etc. as cathode. In this process, active metal aluminum corrode rapidly while the others remain intact. How does the process of galvanizing protect iron from rusting? A clean sheet of iron is dipped in zinc chloride bath. The iron sheet is then removed, passed through the hot rollers and air cooled. This process is called galvanizing or zinc coating or anode coating. If the sheet of zinc is damaged, a galvanic cell is established in the presence of moisture. Iron serves as a cathode and zinc as anode. Electrons flow from zinc to iron, so zinc decays and ferrous remains intact. This is called sacrificial corrosion. Ferrous 3 positive ion plus zinc gives us zinc 2 positive plus ferrous. By this method, the iron is protected from rusting.